Start the recording. One moment, I'll be right back. All right, so go ahead and send that in if you've written one down. If you've just popped in, go ahead and try to write one down. And then after they flow in a little bit, I'll read a couple and we'll write down some stuff. And yeah. There's more people than that. Oh, yeah, there was a set running time, but that's okay. You still had an idea of what the graph could be, so you're good there. All right, I'll give people another minute. It's like 10 people have answered me. This is supposed to be less weird because we're all doing it at the same time. You're perfectly fine. Is it Sri? You're good. It's fine. Pick one, write a scenario. Go, go, go. All right, I'll wait till it says 12:05 and then I'll start reading them. Not all of them by any means, but because most of you are probably writing about the same thing. All right, let's see. Some people who did graph 1. Runs for an hour away from her home and then an hour back. Good. Anybody else do graph 1? That's funny. I said not everyone choose graph 1 and then like barely anyone chose graph 1, which is fine. Someone did. So, oh, someone else just did 2. Took Shannon 1 hour to run 4.5 miles from home and 1 hour to get back. Yep. So essentially in this first one, she essentially is running away from home in this first section and then essentially turning around and going right back. So I might say something like, Shannon ran away from home, and I'm going to be like super specific in a way. So I would say something like Shannon ran away from home for an hour before turning around and coming back home. And then maybe if I wanted to also put in there the fact that there was a distance, I could also add on she ran 4.5 miles in each direction. Now I know a lot of people did graph 2, which is great. So what are some of the ones we've got for graph 2? Went on a continuous run. That's a decent word there. Ran 4 miles in an hour, 8 and 2 miles. Really good. Okay, is walking 4 miles for 2 hours. 4 miles an hour for 2 hours. Sorry, good. So yeah, if you want to actually realize that she's going at a constant speed of 4 miles an hour in that second graph, that's good. Yep, runs 8 miles in 2 hours at a gradual pace. Good, 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 good. Walked 4 miles every hour. Yep. Most of you guys who did graph 2 are saying essentially the same thing. Very, very good. So for graph 2, we could say something like, I personally would have said something like Shannon ran away from home for 2 hours. And she ran 8 miles. Again, if you wanted to say something like she was running 4 miles per hour, also perfectly fine. Essentially, with these things where you have to like write an English sentence to get a point across, as long as it's generally English and gets the point across, I usually don't care about the phrasing. I'm not an English person, I'm a math person. You'll notice over time that I can't spell and I'm bad at grammar. So as long as it gets the point across, I don't care how terrible the English sounds. So for this third one, let's see what some people wrote down for that one. Shannon runs 3 miles for the first hour, then she takes a wee break and then returns home for the second hour. That's awesome. I like that. Cool. Who else did graph 3? I know a couple other people that probably just haven't gotten there yet. Boop, 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 ba-doop, boop is scrolling. Okay. Running for about half an hour and then stopping and then walking again after she stopped. Good. And then I think someone put in a little extra flair in there. Shannon runs for a bit, then takes a break at McDonald's, and then Ubers her walk back home. I didn't even read the Uber part yet. That's awesome. Okay. Okay, I do like this one that just got put in. Graph 3, possibly if she were to run to the track or gym or something, and it was 3 miles away, and then ran back home after. I do like that scenario, and I would perfectly accept it. No problems. If we were being super duper picky, that middle piece would probably be a bit more wobbly, because she's moving. But again, I would perfectly accept that as long as it was like she stopped and stayed relatively in the same spot. Like when I wrote the answers down for myself earlier, I said she goes shopping, which would have been the same problem, where technically it would be a little bit more little wobbly in the middle. But so actually, threes is actually pretty good because if she stops at McDonald's, then she's probably just sitting down eating her McDonald's. All right, so let's put something down for that. I'm gonna be generic. If you want to be super cool and write down the McDonald's one, you can, but I'm gonna be generic and lame. I'm gonna say Shannon ran 3 miles away from her house. In half an hour. She stopped for an hour. Before running home. And again, you could spice that up a little bit if you really wanted to. I really like the McDonald's and the Uber home one. That's cute. I can't move this little. You can't see the box I'm trying to move, but it's not moving. Move, little box. There we go. All right, so that's our warm up. Just looking at these graphs and trying to figure out a generic kind of situation and just being able to read these. So the fact that the one, goes up and then directly back down means that she didn't stop anywhere. She just kind of pivoted and went right back. The second one doesn't turn back around at all. And then the third one has that break in the middle. Really, really good. All right, before we get to continuing our notes, I want to show y'all. I have your homework system set up. Now, I just went through it with my last class. The large majority of people were able to get in. Some people couldn't. So I'm going to show you how you should be able to do it. Oh, I think I need to. I don't think I made this live yet. Okay, hold on one. Oh yeah, I'm in the wrong one. So actually, one moment, I think I have to fix something really quick. Yep, it's not live yet. So while you're waiting on me, if you're not on Blackboard, if you want to try to log on immediately, head to Blackboard. And in just 1 minute, in the course content and modules tab, right about now, so if you're already there, you would need to refresh the page. So let me show you my screen again. So if you're in the course content and modules, you should see WebWork access now. To get to WebWork, you can just literally click on this thing that says WebWork and it will bring you here. I've apparently been logged out due to inactivity. And now this is where for some people it worked and for some people, for some reason it didn't. Your username should be your USC username. So essentially what you use to log into Blackboard, essentially your email without the @ email stuff. And then your password should be your student ID. Your student ID is on the back of your Carolina card if you don't know it off the top of your head. And it has the letter in the front, and be careful because the letter should be capitalized. So if you go to WebWork, hopefully your login will work. If it doesn't, shoot me an email. I have a meeting right after this for a couple of hours, so it will be a little bit before I can get around to it. But you don't have any official homework up yet. So if yours doesn't log in correctly, shoot me an email and I will try to figure out why that's not working and get you set up as soon as I can. But if you can log in, it'll look like this. Why does it say 141? Ignore that. It's 122. But anyway, you should see this thing that says orientation. You don't have to do this, but it's highly suggested. So essentially it's an orientation to WebWork. You can do it problem by problem, and it kind of just walks you through how WebWork is laid out, how you would do your problems, and it also goes through some of the notation. So like most online math things, sometimes it gets a little picky about notation. So this goes over some of the notation that you would need to be careful with. So essentially, whenever you're in a problem, it'll look like this, where you can navigate to the next problems at the top. And then you'll have to use this submit button answer. So even if you type in something, even if you hit enter or anything like that, you need to make sure you hit this submit answers button, which is actually what this first question is telling you about, before it'll go through. And essentially, when it's a question, it'll then, once you submit it, there will be a box at the top. This one doesn't really have anything because there was nothing to fill out. But it'll have a box up here telling you whether you got it correct or incorrect. And then, okay, so towards the back, it starts going over more of the notation. So when you submit your answers, this is what it'll look like. It'll tell you what you entered, what it's reading it as, and whether it's correct or incorrect. So I would suggest going through the orientation just to be aware of kind of how WebWork works. But that's where all your homework will end up. Your first homework will go live on Monday. It'll be a Monday to Monday. I know we don't have officially have classes on Monday, so maybe I'll put it up on I'll put it up on Monday, week to week. So of course you don't have to start it on that Monday. You don't have to do anything if we don't have class, but it'll go live on Monday and be due the next Monday. And yeah, that's it. Oh no, the other thing is one of the first things you should do when you do eventually get logged in is to hit user settings and to change your password. So change it from your I mean, you can keep it if you want, but I would suggest changing it from your student ID. So hopefully if you use your USC username as the username and then your student ID with a capital letter in the front as the password, hopefully it'll work. If it doesn't, shoot me an email. I will try to figure out why it's not working and set you up as soon as possible. So that's that. One other thing I want to say really quick about the notes that I learned in my other class. It might not be as helpful in 122 as it is with my other class that figured it out. But if you open the notes in Adobe Acrobat Reader, and you go over here and you hit fill in sign, and then you hit fill in sign again, you can kind of just, plop around and type things in. Now, again, for this class, it might not be great because, you got to start typing in calculations and whatnot, and it might get kind of tedious. But if you're super, fast typer and feel like that would be a great idea, that's kind of nifty, and I didn't know that that was a thing. So that's a thing. Anyway, questions about any of that hoopla before we get into, I did start recording, right? I did. Our notes. Alrighty. Oh, I guess one last thing. Also, shoot me an email anyway. But if you are one of the people who kind of just got in or back into this class, your web work might not work because I put it in last night. Well, yesterday afternoon, and if you have been added in since then, that might be why. Still send me an email so I know that things are bad for you. But that might be part of the reason for some of you. Anyway. All right. No, that wasn't the thing I wanted to say. Good Lord. So the last thing I want to say before we start our notes is remember, now don't panic if you weren't aware for some reason. There's the quiz today, but remember that it's just a diagnostic thing. It's counted on completion, not correctness. Towards the end of class, so you will not find it yet, but towards the end of class, it will be on Blackboard in the assignment tab. It'll only pop up during the last 15-ish minutes of class, so that no one gets distracted by it. But that's where it will be. Last 15 minutes of class, generic diagnostic, don't panic about it, quiz. All right. Now, let's get to the point. Actually take some notes. So it's 12:20, and so that gives us about 15 minutes. Good. As always, let me know if I'm going too fast, if I scroll up too quickly or anything like that. So points where a function crosses the horizontal axis are going to be called horizontal intercepts. Horizontal intercepts. Horizontal, yeah. Intercepts. And these intercepts are going to take the form of a coordinate point x, 0, or whatever variable you're working over. And if we have some I feel like that wording is, I don't know. Are you saying that you can't see what I'm writing? Can you see it now? Hooray! Okay, cool. So horizontal intercepts. No, you're fine. You're fine. If you can't see something, then I need to fix it. All right, so if we have some random graph, that's a beautiful graph, isn't it? We have horizontal intercepts here. Now, usually in life, we would refer to these as x-intercepts. The reason they specifically say horizontal intercepts here is it's not always going to be an x variable. Sometimes it's a t, sometimes it's a p, sometimes it's a q, so they are just trying to be super generic, but really it's essentially an x-intercept. And then points where the function crosses the vertical axis would be our vertical intercepts. Vertical intercepts. And those are going to take the form of some 0, y, or whatever variable is on the vertical axis. Usually, we usually think about these as y-intercepts. Now, the thing with vertical intercepts is if it's a function, which most of the things we are going to work with are, it's only going to have one. And really super quick babble. The reason is if you don't have a function, so remember a function has to have, every input only has one output. So if it has two outputs for that input, so it would have two vertical intercepts, and it doesn't have to necessarily be this circle, but anything that would have two vertical intercepts would not pass what's called the vertical line test, because essentially it has this input of 0 having both of those outputs, which is bad. So that's why we'll only ever have one vertical intercept. That was just kind of a side note. So we can have as many horizontal intercepts as we want. It'll be based off of the function, but there can be, as many as necessary. But for vertical intercepts, there will only ever be one, if it's a function, which is what we are working with. So let me try to leave that part in there. And I'll hold on a second in case people are catching up. Again, I'm not kidding about stopping me whenever you need to. Sometimes I forget that you guys are writing not exactly as quickly as I am because you have to actually look at what I'm writing. So, problem 7. Let 360 minus 20t equal h. Represent a hiker's height above a canyon floor in feet after t minutes. Find and interpret the intercepts. So I'm going to go ahead and split this up. So we're going to have two intercepts, a t-intercept and an h-intercept. I feel like starting with the h-intercept. So for the h, sorry, I said h and I wrote t. I want to start with the t-intercept. So for the t-intercept, the nice thing about intercepts is whenever you want one of them, the other thing is 0. So if I want the t-intercept, how we're going to find that is we're going to let the h value be 0. So whatever which one you want, you set the other variable equal to 0. So we take this function that we're given, and we set h equal to 0. And then we go ahead and solve for t. A lot of times I won't write out all of the algebra for these, but if you ever need me to write out the algebra, just let me know. So I would add the 20t over to the other side. That's something. And then divide both sides by 20, which for some reason I'm blanking, 18. So t would be 18. And again, if there's any intermediate step that I ever skip algebra-wise or otherwise, just ask me, how did you get from that line to that line? So we've got t equals 18, and I'm going to come back to the interpreting piece in a second. So I've found the t-intercept, it's 18. So now let's go ahead and find the h-intercept. So for the h-intercept, again, if you want one of them, the other thing is 0. So since I want h, t is going to be 0. So we have 360 minus 20 times 0 equals h. That one's really nice because there's not much algebra to do because anything times 0 is 0. So 360 is h. And our h-intercept is 360. And now I want to interpret these. Now you want to be really careful because what I see people doing a lot is that will essentially pair those two together, and they will interpret it in terms of a time of 18 and a height of 360 together as one point. That is not a thing. These are two completely separate entities. Sometimes they can be the same point, but the large majority of the time they're going to be separate. So you have to treat them as separate things, so we need two different interpretations. So this first one is technically 18, 0. T is 18, h is 0, because that's how we found it. So if I want to interpret this, if t is time, it's 18 minutes, and h is a height in feet above a canyon floor, so height of 0. This is essentially telling me after 18 minutes, there's 0 feet above the canyon floor, or they're at the canyon floor if you prefer. So I would say something like after 18 minutes, the hikers are 0 feet above the canyon floor. Again, if you prefer to say they're at the canyon floor or something like this, that's perfectly fine as well. Ooh, that's a really good question. How can you tell which is the vertical and which is the horizontal? So super duper good question. How do I wanna answer it? What we've got here. So we've got our function here. So notice that the h is by itself and that the t is the thing that's inside of a bunch of other hoopla, right? So if you think about it, when we usually have a function, it's usually y equals f of x, right? So the y would be by itself and the x would be somewhere and a bunch of other stuff. So the thing that is solved for, the thing that is by itself, well, I do want to be careful here. Let me backtrack that question, that answer a little bit. because someone could be really tricky, and then what I was about to say would be a lie. Um, in terms of how this question is stated, you wouldn't have enough information. So I should say that it's not always necessary to classify one as vertical and the other as horizontal. The main thing to take is that we have these two intercepts and that it would be where it's crossing that axis. Whether that axis is the horizontal or the vertical one, with this information, we don't know. Now, for this question, we don't care because we just need to interpret it and it doesn't matter. The interpretation doesn't matter which one it is. The extra information you would need to be given is essentially which one is a function of the other. So if you remember the other day, we would have phrasing as like h is a function of t, which would give us that h equals f of t. If you have this phrasing and you know that it's actually in this format, now I clarify that in a second, and you know that it's this in this format, then the one that's solved for would be the vertical, and the one inside would be the horizontal. Now you might ask me, okay, well, we have h equals here, and that's why I started going that direction. But if I want to be actually picky about being 100% correct, they're not telling me which one is a function of the other. So to answer your question, why did I suddenly blank? It's usually not a big deal about classifying it as a vertical versus horizontal. It's just a factor of t-intercept, h-intercept, x-intercept, y-intercept. If you do need to classify them, you will need more information. You will either need a graph where it shows you which one is which, or you will need this verbiage to tell you how to set it up. Is that an acceptable answer to your question? Does that make sense? Sorry, it's like super wishy-washy. If they don't give you more information, it's kind of like, well, are they trying to trick you or are they being nice and just setting it up in the right way? Because sometimes people are tricky. This little box that you can't see is in my way. There we go. All right. So we got that interpretation down. We still haven't interpreted the h-intercept yet. So h. Why am I writing down h-intercept? I do want to write down the point though. So for the h-intercept, t was 0, so we would have 0, 360. So here we would have 0 minutes, 360. So if you wanted to be, formal, you could say after 0 minutes, they are 360 feet above the canyon floor. I never like using at 0, so I usually use a bit more quote unquote better English for those. So I would say something like they start 360 feet above the canyon floor. Again, you wouldn't be wrong if you said after 0 minutes, they start 360 feet above the canyon floor. But the phrase after 0 minutes, I hate it, so I avoid it. So that's how we would interpret those. Questions, concerns on that before I go on to the next one? All righty. I'll wait like 5 more seconds before I scroll down. Teaching online is so weird. All right. And now it's not scrolling. There we go. So something everyone wants to think about, student debt. Kayla just finished college and finds that she's $66,000, has $66,000 of debt in student loans. Determined to pay it off and figures she can pay $1,100, good for her, on her debt per month. Let D equals F of T be the amount of debt that Kayla has on her student loan T months after she began to pay it off. So in this case, just to try to really clarify it, Michaela, here, since we're given the actual format D equals F of T, D would be the vertical and T would be the horizontal. Again, we usually don't even refer to them that way anyway. We'll just say T-intercept and D-intercept. But if we were asked to classify them, then we would be able to do so here. So we're asked to interpret f of 12. Oh, and also we're in a fantasy land where interest doesn't exist. So we're going to interpret f of 12 equals 52,800 and include our units. So if t is that 12, so if the 12 is a t, that would give us 12 months after she began to pay it off. And so our d value is the 52,000. And so that's going to be the amount left. So that'll be in dollars. So this will be something along the lines of after 12 months, she has that 52,800, put the dollars on there, or if you want to write dollars in the back, that's fine, left in student loans. Now, part B, it essentially asks the same thing, but it doesn't actually give us the dollar amount. And that's perfectly fine. And that kind of thing is actually going to pop up every once in a while, where it wants you to interpret something without giving the other value. And you just have to not panic about not having the other value. It's just essentially we don't know how much she owes at that point, but we would say if the T value is 25, that's after 25 months. So whatever that value is telling us the amount left, let's say in dollars, after 25 months. So again, the only thing we don't have here is the actual number, but it's still just telling us the amount, whatever it is, in dollars after 25 months. Let me be a bit more clear. Amount left in dollars after 25 months of paying her student loans. It's good the fact that it's student loans in there somewhere. So then we're asked to see if we can come up with a formula for f of t. So if we go back to the original statement of the problem, there's two pieces of information which really tell us how we can set this up. So she starts with the 66,000, and that every month she takes off essentially $1,100 off of that. So essentially it's a consistent, it's not changing over time, it's always every single month $1,100. So if you think about it, if you just started like listing out a really long formulation, depending on how many months you're working over, it'd be 66,000 minus 1,100 minus 1,100 minus 1,100 and so on and so forth. And the amount of 1,100 would depend on how many months you've paid it off. So if we think about that, we can think that we can actually formulate this formula by taking that starting point of 66,000 and subtracting off the 1,100 times the number of months. And that would be an acceptable function for this. Now, of course, there's part D here, but we're at the point where I would like for you to start your quiz. So we're going to save this for a warm-up on Friday. So we'll answer that. It's essentially what we just did with the last one, finding both of the interpretations, finding both of the intercepts and interpreting them. So we're going to grab that on Friday and finish off that problem then. And we should also be able to finish up the rest of this section 1 notes on Friday. So let me stop scrolling a ton, leave that in there in case someone still needs to get it down. Otherwise, let me make sure it's appeared for you. Bum, bum. It has not yet. Why not? I thought I set it to appear at 35. Hello? Oh, well, okay. Bonk. Okay, now you should be able to find your quiz. So if you head to Blackboard, on the left, you need to click on the Assignments tab, and it should be in there. Let me just write Assignment tab real quick. Assignment tab. You can open it. There's no time limit on this one. There will most likely be a semi-time limit on the ones in the future. Not anything to worry about. It's just that I don't want them open for a long period of time, forever. But you can start it whenever you wish. Again, remember, it's diagnostic, so it'll be graded on completion, not correctness. Once you're done, you are free to leave. Have a great day. I'll see you on Friday. And I'll be around for a little bit if you have any questions or anything like that. But otherwise, feel free to start and leave when you're done.